Let's take a look at the process of solving an equation by factoring by grouping. The equation 5 tangent x times secant x plus 10 tangent x minus 4 secant x minus 8 equals 0 can be factored by grouping. The left-hand side can be factored by grouping, and because that's equal to 0, we'll be able to simplify the equation that way. So we'd like to solve the equation and find solutions on the interval from 0 to 360. So what's important to see, and it's a little bit hard to see because of all the trig functions here, but we have a group of factors kind of multiplied together here. So that represents essentially a term in the expression. And then 10 times tangent x is a second term because it's separated by that plus sign. 4 times secant x is another term, negative 4 times secant x because of the minus sign, and then 8 is finally a term. And sort of looking at those, we have a 5 and a 10, and we have a negative 4 and a negative 8. And so those are both kind of, one number is double the other. And so there's a chance that we might be able to factor by grouping, and we can. If I take the first group, I can think about the common factors there and pull them out, and I can do the same with the second group. So let's see what that looks like. Well, from the first two terms, tangent is a common factor, and so is 5. So I get 5 times tangent of x. And then what's left behind from the first term is secant of x. And what's left behind from the second term is a 2, because 5 times 2 is 10. In the second group, I can factor out a negative 4, and that leaves behind a secant from the first term, and then a plus 2, because the negative 4 times positive 2 gives me negative 8. Now, because what's in parentheses, what was left behind from each of those grouped terms, because those are the same, I can factor that expression to the front. So secant x plus 2, this new factor, it comes from both the secant x plus 2 here and the secant x plus 2 there. From the first group, if I factor out secant x plus 2, what's left behind is 5 times tangent x. And from the second group, what's left behind is just the negative 4. Right, so multiplying things back out, if you think about going from this line to the line above, secant x plus 2 times tangent, 5 times tangent of x would give me that first group, and secant x plus 2 times negative 4 would give us that second group. So those two factors, we now have two factors that equal 0. So the principle of zero products tells me that either secant x plus 2 equals 0, or 5 times tangent x minus 4 equals 0. So from the first equation, I can solve this first equation, and I get secant x equals negative 2, which means that, translating that into cosine, cosine x equals negative 1/2. And so this is going to be a special point on the unit circle. This is kind of a nice point. We're looking for solutions on 0 and 360, so I could use the inverse cosine function to help out here, but it's I hope pretty clear that one solution is going to be 120 degrees, because that's a value that has a cosine ratio of negative 1/2. And the second solution, the symmetric solution down in quadrant 3, is 240 degrees. So those are two of our solutions. In a similar way, using the calculator, this will not be a nice value, so we do need to use the calculator here. I get tangent, 5 times tangent of x equals 4, and so the second set of solutions comes from tangent x equals 4/5, and then using the inverse tangent function, the angle that corresponds to an inverse tangent of 4/5 is 38.65 degrees, 38.7 degrees roughly, And for tangent, the second solution occurs on the opposite side of the circle. So if I add 180 degrees, I get a second solution at 218.7. So our two solutions are 38.7 degrees and 218.7 degrees. So let me put together the final solution. So the solution, we have four angles in the range from 0 to 360 that satisfy the equation. I have 38.7 degrees, 120 degrees, 218.7 degrees, and 240 degrees. It's always nice to have a way to check our work, and so we can do that graphically. If I enter the original expression into the calculator, 5 times tangent of x times secant of x, of course I need to turn that into cosine, so I can divide by cosine of x, and then plus 10 tangent of x minus 4 divided by cosine of x minus 8. And we're looking for solutions between 0 and 360. The calculator, I have it here in degree mode. So if I go to the window, let me adjust the window so I go from 0 to 360. And then we can have a scale, we can count by 90 degrees. And -4 to 4 is a pretty good range for the y values. We could use the Trig zoom option to set up the window, but it is kind of nice to just choose the values directly. So looking at a graph, the solutions are where the graph crosses the x-axis, because that's where the expression gives us a value of 0. Once we have the graph, we can use the trace key to confirm that the points that we found are solutions. So if I hit the trace key and then type in those values, typing in 240 places the cursor at 240, and we see that there's a solution of 0. Similarly, 120 gives us a point on the graph. If I enter 38.7, I'm not going to get a value of exactly 0 for y because of rounding, but we get pretty close, and we can see that that lines up with a solution there. And similarly, 218.7 lines up with a solution over here. I hope you enjoyed the video. Thanks for watching.